DFG Science TV, The Wave Hunters. Do Einstein's gravitational waves rock the universe?
Henning and Alexander have successfully tested their squeezed light experiment. Next, it needs to be transported to the GAO 600 gravitational wave detector. Once installed, the sensitivity of the detector will be improved further. We have a tradition at GAO 600 of always being a generation ahead. And the things that we're now testing in the lab will find their way into the third and fourth generation of future detectors. Henning and Alexander's experiment plays a key role on the international scene as well. After many years, instead of operating an interferometer with normal light, technology has, for the first time, advanced far enough for us to use modified light, something that has only been available for a few years. That will open the door for a broad range of new interferometers, which will make possible unimagined sensitivities. The first proof of gravitational waves is within reach. But the simple proof of gravitational waves, that isn't what we're after. We want to perform gravitational wave astronomy. Extensive planning is necessary in order to realize this goal. The researchers at the Albert Einstein Institute are therefore already studying the possibilities for the next generation of gravitational wave detectors. We're already thinking about what the third generation could look like. And laboratory experiments that won't be used until the fourth generation in 2030 are already being planned. But in the future, detectors won't be installed just on Earth. Soon, the search for gravitational waves will take place in outer space with complex satellite missions. Shortly after the first ideas arose for using laser interferometers to prove gravitational waves, it was clear that space is the ideal place for this. Today, we know that we'll probably never be able to detect low frequencies from the Earth. If we want to hear the deep tones, in other words, the really big, supermassive black holes, then we need to go to outer space, because there, noise levels in the low frequencies are very low. With this goal in mind, an important international satellite mission will start in the year 2020, the LISA Space Observatory. 3 satellites with lasers will span a massive triangle, an unbelievable 5 million kilometers in length, and circle the Sun in Earth orbit. LISA is one of the most important projects in physics and astronomy, and will help mankind acquire new and fundamental knowledge. From the start, the AEI played a key role in all areas of the LISA mission. It's a truly fantastic idea to think that LISA will be capable of detecting supermassive black holes everywhere in the universe.
Supermassive schwarze Löcher überall im gesamten Universum zu detektieren.
Detectors such as the GAO 600 are already searching for gravitational waves today and are collecting data. These massive quantities of data are currently being analyzed in search of gravitational waves. The first detection could occur tomorrow, and each of us can participate. Here at the Albert Einstein Institute, we do, of course, go to great efforts to analyze the data. Today, this is performed using large clusters of computers. Here in our facilities, we've networked several thousand PCs together to analyze the data. In doing so, we've achieved tremendous computing power that was unimaginable just a few years ago. It's a great challenge to filter out the one needle from the haystack of noisy data produced by the gravitational wave detector. Especially considering that we don't even know what it'll sound like when it falls out. But the wonderful thing is that everyone can participate in perhaps detecting the first signal. Download a beautiful screensaver from the Einstein at Home website. This screensaver downloads a tiny piece of gravitational wave detector data and searches for a neutron star in a certain position of the sky. And on your screensaver, you can see exactly which position. And once it's finished searching, it sends the data back to our central computer. And I promise you, if your laptop's found something, we'll let you know. And sometimes, on quiet nights, I imagine what it'll be like when we one day hear the Big Bang.
Visit DFG Science TV for more information. Awaken the researcher within you.